Have you ever stopped to think about the sheer magic behind sending an email, or how a movie just appears on your screen? It's not magic, of course. It's all thanks to this massive, hidden, global web of connections. In this explainer, we're going to pull back the curtain and take a look at the invisible network that basically runs our digital lives.
So here's what we've got on tap. We're going to start with the absolute basics. What even is a network? Then we'll look at the hardware that makes it all work, how your data finds its way from point A to point B, the rules that keep everything from descending into chaos, and finally, how we try to keep it all secure.
All right, let's dive right in. First things first, what are we even talking about when we say computer network?
At its absolute core, it's just this: a bunch of connected devices. That's it. The whole reason for doing this, the entire point, is to share stuff, whether that's a file, a printer, or, a connection to the internet. This simple idea of sharing is the bedrock of our entire digital world. And think about it, pretty much everything you do online, from zipping a file over to a friend to binge watching your favorite show, totally relies on a network. All of these everyday things are only possible because our devices have a way to talk to each other.
Okay, so that's the what. Now let's get into the how. What are the actual physical pieces of hardware that make up these connections?
Well, networks come in all shapes and sizes. The smallest is a PAN, or a personal area network. Think of this as your own personal tech bubble. Your phone connecting to your headphones with Bluetooth, that's a PAN. Step it up and you've got a LAN, a local area network, which is what you have at home or in your office. Go bigger and a MAN, or a metropolitan area network, can cover an entire city. And the biggest of all, a WAN, a wide area network, which connects cities, countries, and continents. The internet, well, that's the ultimate WAN. Now, to make all this work, you need a few key players. Your modem, that's your gateway, your on-ramp to the internet. The router is like the traffic cop for your home network, directing all the data where it needs to go. A switch is a little different. It's what connects all the devices inside your local network. And of course, the access point is what beams out that glorious Wi-Fi signal we all depend on.
So we've got all our devices hooked up. But how on earth does an email you send from your laptop find its way to one specific phone halfway across the world? Well, it's not magic, it's all about addresses.
Every single device that can connect to a network has two critical addresses. Think of the MAC address as a permanent serial number that's physically burned into the device's hardware. It's unique and never changes. But the IP address? That's more like your current mailing address. It can change depending on where you are, and it's what routers use to send your data across the vastness of the internet.
Now, here's a really cool part. Your data, whether it's a photo or video, doesn't travel in one huge lump. It gets chopped up into tiny little pieces called packets, and each packet is like its own little postcard. It's got the destination address, the return address, and a small piece of the message. They might even take totally different paths to get there, but they all get perfectly reassembled at the destination.
For all of this to work, for billions of devices to communicate without total chaos, everybody has to be speaking the same language. They all need to follow a common set of rules. And in the networking world, we call these rules protocols.
You've probably seen these acronyms before. HTTP is what your browser uses to load a website. DNS, the domain name system, is basically the internet's phone book. It translates a human-friendly name like Google.com into a numerical IP address that computers can actually understand. And things like SMTP, that's what handles sending your emails. Each one has a very specific, very important job.
And the TCP/IP model is the blueprint that organizes all these rules. It works like a digital assembly line. At the very top, your web browser creates the data. Then, the transport layer chops it up into those packets we talked about. The internet layer stamps on the IP address. And finally, the network interface physically sends it out over the wire or through the air. The real beauty of this is that each layer only worries about its own job, which makes the whole system super flexible and powerful.
Okay, so we have all this data flying around the globe at the speed of light. It's probably a good idea to make sure our connections are safe, right?
When we connect, we usually have two main choices. A wired connection is almost always faster, more stable, and more secure. But wireless, well, it's all about convenience and mobility. It's that classic trade-off, power versus flexibility. And no matter how you connect, security has to be top of mind.
So how do we protect ourselves? Well, here are the basics. Firewalls act like a digital bouncer for your network, deciding what traffic gets in and what gets blocked. Encryption, which powers things like HTTPS and VPNs, is like taking your data and scrambling it into a secret code that's unreadable to anyone else. And of course, your first line of defense is always going to be using strong, unique passwords and making sure your devices are set up securely.
So, when you put it all together, the hardware, the addresses, the protocols, the security, you get this incredible invisible architecture. It's the silent, humming backbone that supports just about everything we do in the modern world.
This whole system is the result of decades of brilliant innovation. But technology never stands still. And it makes you wonder, right? Now that we understand the rules that built the world we live in today, what new possibilities, what incredible things will the next generation of networks unlock for us?